Hi everyone. So I'm Mike Spencer from Smart Data Foundry, and I'm going to talk to you today about using Quarto with Python and R. So the things you'll learn in this talk, I'm going to cover what Quarto is great at, why you should use it, and some of the resources you need to get started. As I find like that's often the biggest hurdle. It's fine to hear about these great things and go, yes, I totally need to use that. But if you don't have that initial how to get going, it can be really difficult to get started and get some traction and start embedding it in your work. So who am I? So as I say, I'm Mike Spencer. I'm a data scientist. I suppose prior to that, I was a climate scientist. I worked as a hydrologist and did a PhD in snow hydrology, and I've, I suppose, done a fair few different things during my career. I'm not formally trained in software development. So most of what you're seeing, I've learned on the job, or through blog posts, or reading things on social media, or all of those different places that we learn things and help ourselves grow. I am a principal data scientist at Smart Data Foundry. I'm the principal data scientist at Smart Data Foundry, and I run a small team of data scientists working both in R and Python, doing a whole range of things from kind of DevOps and platform type development through to dashboards and interaction and data engineering and all those kinds of things going with that. You can find me on LinkedIn and also on Mastodon. I'll make these slides available afterwards. Andrea will send out a link so you can follow through on clicking, so you don't necessarily need to write down any links as we're going. So first up, what is Quarto? So Quarto is a way of bringing together text information and information generated by code into outputs. So as that first bullet's saying, we can weave together that kind of content and that discussion along with executable code into a finished product. And the key word here is render, and that's the language that that Quarto uses to create these types of output. And so we can author content using Markdown, which I'll cover in just a moment, and incorporate within that output from executable code. And if some of this sounds vaguely familiar to those who've maybe come from more of a computer science background, this is really closely aligned with Nuth's work on literate programming from the 1980s, and a lot of that kind of mindset is really key to reproducibility and open access. So if you're looking for jobs outside of academia, you might come across the phrase RAP, a reproducible analytical pipeline. They're really common in government analysis jobs, and this sort of idea of how do you take raw data and work it all the way through to your published website or PDF or sort of whatever's coming out down the end. And a lot of the tools that are going on there are sort of like people have mentioned in the chat are Markdown, and it's newer and replacement variant Quarto. And what this enables us to do is to separate our input, our code, and our output, which gives us a whole improvement in reproducibility. If our code and our output aren't tangled together, we can rerun our code on new input and get new output from it, and we can have that distinction, manage those things with the best tools that are available to manage them, rather than say having a tangle of output and input and code, trying to go through version control or heaven help us, something like SharePoint. So what is Markdown? Markdown was created in the mid-noughties, which is starting to seem like a very long time ago, as a lightweight formatting language. I think partly in response a bit to HTML, which for those of you who have used it, isn't enormously painful, but there is kind of quite a lot of syntax that goes around that, whereas Markdown is extraordinarily lightweight. So it's really easy to read and to write. It's really commonly used in things. So if you're writing GitHub, you can include Markdown formatting. You can use it in Jira. Amazingly, you can use it in Microsoft Teams. I'm not saying it's the most reliable. Teams is the most reliable way to do it. You can also use it in sort of fairly standard note-taking apps like Logseek and Obsidian and all of those kinds of things. So it does appear in lots and lots of places. I am just going to open this link and we can have a quick look. Let me make that a tiny bit bigger. So what we end up with are things like hashes to change our heading levels. We can also do that with sort of underline type things. We can split things with paragraphs by leaving blank spaces. We can see that compared to HTML here. We can add things in bold with sort of simple asterisks, and there's so all of the kind of things you'd expect, italics and all of those. Yeah, so you can follow through that basic syntax guide, but like I say, it's really straightforward to get started. So what is Quarto good for? And this is maybe a degree of overlap to how do we use it in my team. So we use it a lot for exploratory data analysis. I suppose particularly those who are coming from an R background, that's more mature in that space for the exploratory data type work. And I'll show a bit of an example of that later on. We use it for various types of reporting, so particularly for quality assurance and run logs. If we've got a sort of a data engineering task going, we'll often write output as part of, or logs and output as part of that engineering pipeline, which we then pick up with Quarto towards the end of the pipeline and generate a sort of a visual overview of how that run went. We use it a lot for technical notes, and I've got an example of that in just a minute, where we're incorporating kind of brand formatting and all of those sorts of things that enable us to use it in that sort of more corporate or professional type of way. In terms of the types of publications, we can do PDF, we can do EPUB, you can make whole websites. There's a whole massive range of things, sort of lots of which I haven't yet tried, but they're there, and I'm going to demonstrate how easy it is to switch between those different outputs in a few minutes. So I mentioned there about technical notes. This is some work that a colleague, Nathan, did on net zero affordability in Scotland. So we can follow through to the DOI and see this on Zenodo. And just as soon as it renders, we can see we've got some nice branding going on, sort of nicely laid out. We've got some footers. I'm not saying any of this is rocket science, it certainly isn't, but I think like the ease of being able to make this this kind of professional output is orders of magnitude better and more reliable than something like Microsoft Word or those kind of what you see is what you get type editors. So we've got some charts that were created within Quarto itself, and Quarto renders that code and incorporates the output for us. And we'll see some examples of how to do that in just a minute. So I guess maybe the key question, especially those who are coming from a Python background, is how's Quarto different to a notebook? And I'm particularly thinking Jupyter here. And Jupyter is great because it lets people get started really easily, but it does come with quite a lot of baggage. One of the really big ones for me is that Quarto is a plain text file, and Jupyter isn't. Jupyter combines that output and that code all into sort of that same thing, which often has this this tendency for people to interact with it. And I'm sure we've all done or have had colleagues who have done, where you're like, oh yes, if you're working with that notebook, you have to run cell 1 and 3, and then you can go back and run cell 2, because it's not been written and managed as a completely executable script. And And hopefully it's fairly apparent the kind of challenges for reproducibility around that. If it requires a human input and knowledge to know which order you need to run those code chunks in. So all of this means that Quarto works much better with version control, because we are just looking at a plain text file. We can do that line by line sort of comparison and diffing. It's much easier to share results and or code because we can do those separately. They're not one and the same thing. And it really encourages us as users to write executable scripts that we want to be in a place when our work's ready to be shared, that we can hit that render button or run that render script and generate that PDF output or website or whatever else, so that others can read and see our work, and we're not kind of dependent on all these potentially out of sequence code chunks and all the sort of fraught things that go with that. So I'm bravely going to do a live demonstration. So what I'm going to first do is make this a little bit smaller. And I'm going to move my notes around so I can see what it was I exactly wanted to show you, or maybe so I can remember exactly all the things I wanted to show you. So I'm going to start off in R. I'm going to do some Python stuff in a few minutes. And what I'm going to do first, so we've got our studio open here. I'm going to just make that a bit bigger, I think. Yes, just for now. I'm going to open up a new Quarto document, and I'm going to call this our example. You might need to suffer my typing a little bit. Maybe I should get a quieter keyboard, but I'm probably not going to. Right, so we'll create that. I'm going to save that in my R example directory here. We'll just call that reg, and we'll hit save. And so we've got our reg.qmd. So we can see that our studio's pre-populated this with some boilerplate or template type code here. So we can see the R example I've added has now become part of the title. The name that I added is become the author, and the format I chose is here. So this section at the top is called the YAML, and that tells Quarto how to handle the output. We can see some of the syntax highlighting I talked about a couple of minutes ago. So we've got sort of 2 hashes for that second level heading. We've got a web link in here. We've got double asterisks for some bold text. And then quite crucially, in the bit we haven't seen so far, is we've got code chunks. So for those who've seen Markdown before, we use these backticks. They're in the top left of your keyboard if you've not used them before, to make the code chunks. So we can use single ones for inline, or we can use sort of rows of 3 to create code chunks on its own. So what I'm going to do first off is I'm going to again make this slightly smaller. Jiggle this around a bit. Let's open up the directory that we're working in so we can see this. Our example QMD, it's possibly a bit small, but exactly the contents of that directory aren't overly exciting. And what we're going to do is we're going to hit this render button here. So we can see Quarto starts, it runs through a bit, and we now have an HTML file here. So if I open this with Firefox, and it's open there in the directory, or well, in the page that I had a minute ago. And we can see that I've got sort of the different parts of that file. So we can see we've got our high level code, we've got our title, we've got things about the render in the bold, we've got those code chunks here. And if I move across, we can see those matching up. So we've got that 1 + 1, which creates an output of 2. But in this example here, we've got a flag on this of echo is false, and that means we hide chunk, and we get our 2 × 2 gives us an output of 4. And we can see we've got our sort of code type style embedded in there. Right. Fantastic. What I'm going to do is I'm going to start making some changes to this file, so we can see some of the things that might be useful as we go along. So the first thing I'm going to do is I'd like to add a date. I think it's a useful thing to have, is knowing what the date is that your code or your script was run. I think it's a really useful thing, and I quite like the date format to be ISO. So I'm going to hit render there, and this page should magically refresh. And we now have a published date on that telling me when that code was run. And you can start to see how this would be really useful in terms of like a QA log type output that we're always getting to know. We can just open that HTML or sort of whatever other format we might have made and see what or when that piece of work was done and written. So talking of things being changed in whatever format, let's change this to PDF, and I'll save that and hit render. So it's going to close that one down, a bit like it's closed down my slideshow. I'll have to open that again, but that's fine. And we've now opened up the PDF that I've just made. So as you can see, this is exactly the same source file making this. The only change is that I've now outputted to PDF instead of HTML. So we've got a PDF file here. We've got all the same things that were going on. We can see our code if we want to. We see the results. We can hide our code. We can still see the results. We're still getting our date. We've got clickable links and all of those good things going on. I think for the purposes of this, I'm going to switch back to HTML because it is slightly faster. And I'm just going to re-render that, and we'll see what we get. Fantastic. So it looks like it did a minute ago. Great. So I talked about inline results, and this, in its current format, isn't actually executing anything. It just enables us to have that kind of monospaced formatting around our code to see what's going on. But if we wanted to include some text here, so something like the sum of I don't know, 2 plus 3 is, then we can use our backticks, but we can tell it what language we'd like to use. And we can say, 2 plus 3, maybe put a full stop on the end so it looks like a sentence. And this should now execute that piece of code and output that as, there we go. So we've got that sort of live calculation to provide that sort of update. And you can start to see how powerful that can be if you've got tables that you've read in that are maybe they're dynamic, maybe it's a report you're generating for your department or something around I don't know, number of days leave per quarter or something like that, and you want to have sentences describing kind of what's going on, and suddenly like this starts to look like a really powerful way to incorporate these things. Or it could be that when you're writing an academic paper, you want to have the numbers directly calculated in the sentences that you're writing, rather than having to sort of rely on that human error prone challenge of sort of copy paste or typing numbers out and then forgetting to update them as your data improves or is changed over time. So that's it's a super powerful way of handling things. We can also, if we are working as a lecturer and we want to include maybe notebooks for people to work through, or a document with code in it actually want to execute it, we can also hide our code. So there are lots of great shortcuts in RStudio. I'm just going to do the Control-Alt-I to bring up a new code chunk. What we can do here is I'll add in one of these flags, and I'm going to do eval equals false. So this lets us include code that we're not going to execute. You know, maybe it's something like we want to do something for a coding exercise, and we want to see if someone can spot what's gone wrong. So that's absolutely fine. Hopefully everyone can see that I've mistyped CSV in this here. So I wouldn't actually want that to execute, but in terms of that being something that we might want to present to students, that lets us include things that don't necessarily run, but we can still see them as an output that, you know, could be an example of how something would work, or in this case, not work. So that's a super powerful thing. Right, in terms of how I often develop, so I might do, I tend to do things quite interactively. So I might, I suppose in a way that I might do a notebook, but in this case, I'm always writing an executable script. So I guess, you know, I might give a title of example and add in a code chunk. Maybe my first one's about, let's make some data. This becomes quite useful, particularly in RStudio, because we can see the labels of our different code chunks to see what's going on. And when we execute that, can we see them? Yes, it's telling us kind of what's going through and being executed each time. So maybe I'll make a data frame with where the X is true. I think that's what we want. And we'll make Y equal something like around random numbers of 26. So I'm doing this totally off the top of my head, and what I might then do just to check that makes some sense is I can click on this button and execute that code chunk, or I can do a Control-Enter, and it prints out that data frame, and I can see that what I've got here is actually what I intended to do. I've got some numbers and I've got some letters next to it. Fantastic. So maybe I'll just call that X. And then I might go on and do another code chunk, and you know, maybe this one I'll label it as plot. We'll see how good my memory is on base plot, but I think it should just plot that. Let's see. Oh, object not found. There we go. Everyone loves a live demo. So I've obviously not run this code chunk and assigned that, and I suppose I could see this because it just outputted to there before. So I can go back and run this code chunk again, and now if I run this one, I'm getting some grouchiness. Does bar plot work? No. Tell you what, let's do this with some ggplot to save me trying to remember some syntax. And we will pass it X, and our static can be X and Y, and our geom can be a, does that want to be a col? I think it's a bar, isn't it? Let's see. Oh, it did not write. Oh, I see. There we go. And this one will want it as well. Okay, so it wants that to be John Cole. And we can see, while I'm obviously making lots of mistakes, that's kind of actually how most of us code as we're going along, that we're trying ideas out, we're running them, we're seeing what's happening, and we can hopefully hit that again. There we go. So we now have a nice plot of our random numbers, around a sort of a mean of 0 and a standard deviation of 1. I think the defaults were, and we can see that all works in the way we expected it to. So now if I save this and render this output, so we can see as it's going through, it's worked on its different bits and bobs, and now we've got some extra things on here that we've got our example where we've assigned our data frame to X. We've then plotted that out. We've now got that plot there. So we've seen me fairly clumsily work through that in an interactive way and then generate some output that's now encapsulated in a script that runs. So I could share this plain text file here with a colleague to run somewhere, or I could share this output as a PDF or as an HTML or sort of whatever other way that I would think was appropriate to help get that information across. I think the last thing I just want to show is tables. So let's I'm just going to the function I want to use is called Quarto in R, and I'm sure there are very similar things in Python. So I'm just going to use Quarto. Again, we can try out this code chunk, and we can see that we've got some different formatting going on here. For those who are more familiar with Markdown, this is Markdown's table syntax. So now if we go to render this, it'll have a little bit of a think through, zips along, and we now have sort of a fairly nicely formatted table of our output there that we can use. Okay, fantastic. I'm now going to bravely switch over to doing a Python demo. For those of you who know me, this is bravely because I don't write in Python very often at all. So the first thing I'm going to do is fire up a Jupyter notebook. And it will zip along and do its thing. Fantastic. So in some of the guides that I've got links to later on, there's a Jupyter Notebook example, and so that's what I've grabbed here. So we can open that up. It's got a lovely down the plug hole type plot. So what we can see is we've got the YAML like we had before, and we've got a code chunk using some NumPy and matplotlib and all of those kinds of things to make this make this down the drain plot. So I'm not going to make any changes here because actually just what I want to demonstrate is how we can go from a Jupyter notebook to a Quarto type output very, very easily. So the first thing I'm going to do is I'm going to fire up a terminal in Jupyter. And what I'm going to run is I'm going to run Quarto render, and our notebook is called hello.dwells.i p, y, and b, and we're going to output that to HTML. I appreciate all of that text is possibly quite small, but these things are in sort of the guide that I'm linking to at the end of the talk. So let's navigate now to the Python example where we can see our Python notebook. We now have this hello.html that we've made from Python. So that's a Jupyter notebook rendering to HTML via Quarto. And you can see like this is sort of a super powerful thing that we can produce and start sharing with people, and we're not dependent on them having Jupyter installed. We can show or hide our code and all of those kinds of things. Just going to move this down as the Zoom things are hiding what's going on a little bit here. But what we can also do is I can change this HTML and I can put in a docx and we can run that again. has a bit of a think. We can see we've now got a new file in here. So I can click on this and open it in LibreOffice. And we now have rendered that Jupyter notebook to a Word document. So in this case, we've still got our code included. We can see our plot. We've got a sort of a figure caption for that plot, including with some hyperlinking there, I think, that would jump us through to this plot. So you can suddenly see how like enormously powerful this is in terms of being able to communicate our work beyond sort of the audience that we started with. So the next thing I wanted to do is a little bit more Python demo. So I'm going to close that. I'm going to close these Jupyter things. And I'm just going to shut down this Jupyter panel. Fantastic. So what I have done, and I'm going to just jump back to our studio, not because I'm using it interactively, I basically just needed somewhere to write a text file and I had it open already. So the code from the previous Jupyter notebook, I've now dropped directly into a Quarto document. So we've still got the same YAML at the top. I've included a bit of blurb about Quarto, and our code chunk to make our circular plot is now sat within this Python code chunk. So whereas before we were executing R code, we're now executing Python code. So it looks super similar, except it's now a plain text file. And so what I should be able to do here is that I'm going to use this terminal this time. Basically, as before, I can do a Quarto render. This file is called test. I'm pointing with my finger, that's not helpful. This file is called test.qmd. So over here, I'm going to render test.qmd. And I can leave it to that and it will default to HTML. So if I jump back up here again, we can see it's doing some bits and bobs. It's made us a Jupyter notebook, which has sort of disappeared, and now we have a test.html. So I'm going to click on this, and pretty much as before, we can see almost exactly the same thing that we had, except we've now got the kind of the slightly different inputs, including some clickable links and all of those things. There are obviously some bits I've glossed over here, particularly around Python environments. For the eagle-eyed of you, you can see I'm running the niftily named myenv here. For those who'd like to know more about Python and indeed R environments, you should have a look at my colleague Harry Peaker's talk that he did last week, which I think should be coming out on the SSI channel in the next couple of weeks or so, when he talks a lot more about how to set up environments for Python and R to sort of really aid that reproducibility. So as before, we can go in here and we can change this Quarto render. We can add a to flag, and we can add something like a docx. And this will zip along, and there we go, get our docx file out, which will look remarkably similar to the other thing we've just looked at. We can obviously output to sort of PDF or all of those other formats, blog pages, kind of you name it, you can pretty much do it as examples as well. The last thing I'd like to show interactively, and I'm just going to open up up too many levels, is the presentation. So the presentation that I've been doing is also made in Quarto. So I'm going to zip along to the part that I got to. Here we are. If I move to this file, so we can see we've got Quarto for Python and R. We've got my name. We've got the sort of the logo appearing. Let me just jump over. We've got a logo appearing in the bottom corner on each of the slides, and we can start to see those that we're using those headers to denote a new slide each time. And we're now somewhere down at the in action section, which is a slide without any content on. And you can see we've got a couple more slides coming up. So yeah, I think like that's another super powerful way for us to be using Quarto is this that we can create presentations. So I haven't included much code or any code really in this presentation, but certainly like Harry's code that he did last week, he got some really neat tabs where he was demoing things in R and Python, and he could live flick between, sort of with a toggle of a button, the R version of the code and the Python version of the code. So you can suddenly get some really neat interactivity going on. If I've got a minute at the end, I might show a little bit of that, but I'm looking at the time and suspecting not. So one of the, let me make this a little bit bigger. So one of the things I demonstrated there was the interactivity element in R, and I didn't demonstrate that in Python. This is, I suppose it's been on my list of things to learn for a little bit of time, and I think that space is becoming much more mature now. So this is a screenshot taken from the Quarto docs showing a VS Code editor with the Quarto plugin that lets you do that, run a cell and get some output alongside things, and see kind of all those things going on in that interactive way I've just shown with R in R Studio. The company behind Quarto is called Posit. Used to be called R Studio, but they, I suppose, decided that they wanted to be a much more rounded organization, not just cater to R. So they became Posit, and they produce tools for R and Python now, which is largely this kind of why Quarto came out, that I think R Markdown is fantastic and is enormously mature. But in order to use it with Python, it does require a much higher degree of hoop jumping than Quarto does. I mean, like, hopefully I've demonstrated that actually Quarto and Python and Jupyter play together very nicely, and really haven't taken very much effort to set up at all. And that's a big reason to think about sort of moving from R Markdown through to Quarto. And I think, like, for me, that interactivity that I demonstrated in R Studio is something that I would really want to have embedded before I started using Quarto for Python. And so I think some of these things here in VS Code, but also the sort of from that VS Code family, Posit are also producing an IDE called Positron, which has some of these things baked in by default. So I think that would be a really interesting space to keep an eye on. So some links and further reading. It's kind of cropped up a few times. The Quarto.org website has loads and loads of really useful things on there. There's a whole load of guides on, and actually lots of languages like Julia and Python and R and all sorts of things, but I've linked to the Python one there. There's some getting started things there. That's going to take you to the Jupyter page, but there's a tab. Actually, I can probably show this quite easily. There is, when it loads, there we go. Let's make that a bit bigger. We've got a tab at the top, so you can choose what tool you're working in. So at the moment, we've got Jupyter enabled, and we can see, actually, this should look very familiar because I've just shown you very, very similar things to this. But we could pick VS Code, or we could pick R Studio, and the page refreshes and shows you how to get started. So back to my slides. A lot of the things I use for this presentation are in sort of the Quarto.org presentation examples. The Turing Way book from the Turing Institute's got lots of really good stuff in about reproducibility generally. Not so much on Quarto, but it is a really, really good resource. And lastly, this is the link through to Harry's talk last week, as sort of this foundational piece about encapsulating your work in a way that lets others pick it up. I suppose like my last shout out, particularly for those that are in Edinburgh, sort of as a few folk in the chat have mentioned, is we have a couple of tech meetups in Edinburgh. A couple of the sort of bigger ones, or more language specific, are Edinburgh and PyData Edinburgh. There is an Edinburgh session next Thursday. So yeah, if you're free, do come along. And this is a really great way to see how different people are using these tools, an opportunity for you to talk and share your ideas and the things you've learned, and I suppose the things you might want to learn as well. So finally, in summary, Quarto is a really excellent way to share output from your code. And it's also a really good way to share your code as well, separate from your output. It's really, really easy to create professional quality output. And in terms of that reproducibility bit, pretty much completely eliminates all of that kind of copy paste from a from one file into a Word document and all of that you can do that far easier, which helps make your work reproducible and saves you enormous amounts of time and reduces mistakes and all of those other things. And more broadly, it's really good for career development. Certainly when we're recruiting, it's one of the things we look for is how kind of what things, everything from what sort of IDE someone's used to what's their awareness of this kind of landscape around publication and reproducibility. So I think I am about there. I'm going to stop sharing and hand back over to Andrzej to take us through a Q&A.